I could compare my car to an airplane. Now we're getting pretty dissimilar. Both do have engines, though, so I guess there might be some similarities that could help me. And I guess I could compare my car to a canoe. But now, I guess the only similarity we're going with here is that they're both vehicles. You can use both these objects to get from point A to point B. But now we're really far removed as far as similarity is concerned. I don't know that I'm going to be able to learn much of anything by comparing my car to a canoe. Alright, so that's the idea of similarity. The more similar, the better. Now, the idea of what it means to be relevantly similar, let me just give you an example and hopefully this will highlight. There happens to be a number of things similar between myself and Kobe Bryant. Kobe Bryant is a professional basketball player. Both of us are about the same age. Both of us grew up right outside of Philadelphia. Actually, that's probably it as far as similarities go. But, you know, good enough. We're both around the same age. I think we graduated high school the same year, and we both grew up right around Philly. So these are some similarities between myself and Kobe Bryant. Here's a really bad argument I could give. Kobe and Bryant and I are pretty similar. Both of us grew up around Philly. Both of us are around the same age. So Kobe's in the NBA, therefore I'm probably in the NBA as well. Well, obviously that's a bad argument because even though I gave you similarities, neither of those similarities are relevant to the conclusion of me being in the NBA. The NBA being the National Basketball Association, the professional basketball league in America. The fact that I'm about Kobe Bryant's age isn't good evidence that I'm in the NBA or that I'm really good at basketball. The fact that I grew up around Philly has no relevance to whether I'm in the NBA or not. Neither similarity I gave offers much evidence in support of that conclusion. Now, on the other hand, if I were to compare Kobe Bryant to someone else, like, say, LeBron James, and I would say, Kobe and LeBron James are pretty similar. Both are fantastic basketball players. Both are two of the best basketball players currently alive. So Kobe Bryant's in the NBA. LeBron James is probably in the NBA as well. That would be a much better argument by analogy, because now the similarity I'm offering you as evidence is relevant to the conclusion as to whether LeBron James is in the NBA. Whether you are one of the best basketball players on the planet is hugely relevant to whether you are in the NBA. So that's the idea of what it means to be relevantly similar. And that's an important factor when evaluating an argument by analogy. So just to highlight before we move on to another version, when you're looking at an argument by analogy, you want to ask those three main questions. Are the premises true? Are the objects being compared similar to each other? And are the objects being compared relevantly similar to each other? Alright, so this actual argument here, Paley's argument by analogy, is a specific type of what is generally referred to as an inductive argument. Let me tell you a little bit about inductive arguments. The fancy definition of an inductive argument, this can actually be found way back on page 42 and 43 of your textbook. But the definition of an inductive argument is a generalization that uses specific observations as evidence for that generalization. That might not help you so much, so let me give you an example of a particular inductive argument. Nearly every cat I have ever observed in my life, I've wind up seeing meow at some point. So I have two cats, I've seen them both meow. My sister has two cats, I've seen them meow. I grew up with a cat, and I saw it meow a lot. I go to PetSmart a lot, and I hang out just watching the cats there, and I see them meow. And it just turns out that nearly every cat I've witnessed has meowed. So I'm going to conclude from that most cats in the world meow. Even the cats that I've never come in contact with in my everyday life. Those cats that live in China, that live in India, that live in England, that I'll never come across in my life, I'm assuming, based off of this evidence, that they meow too. So this type of reasoning takes specific observations that all seem to fit this same pattern. I see a cat, it meows. I see another cat, it meows. I see this third cat, it meows. Just about every cat I see meows. This pattern just keeps happening over and over and over again. And I conclude based off of that the world works in that way. There is this general pattern that flows throughout the world. In this case, the pattern is cats meow. And so this is what I think of as learning from experience. We all do this from a very early age. We start as a child and learn the meaning of words. The word apple refers to red fruit. How do we learn that? Because we hear the word apple so many times around a red fruit. After 4 or 5, 10 times of hearing that, we conclude, oh, that sound apple must mean that red fruit. Likewise with all sorts of things. Science is largely based off of this type of inductive reasoning. How do we figure out that what goes up must come down, that there's a law of gravity? Well, we've seen it happen so many times, and we've repeatedly observed it over and over and over again, that we know the next time we throw something up into the air, it's going to fall back down due to gravity. Alright, so the inductive version of the design argument takes as our observations all the human-made objects that we see around us. So our premise in our inductive version of the design argument is as follows. All complex, ordered, and functional human-made objects are intelligently designed. They're obviously made by humans. And we conclude from that nearly everything, even the stuff we haven't observed to be intelligently designed, is probably intelligently designed. So it's likely that all complex, ordered, and functional objects are intelligently designed. And that includes natural objects, objects like eyes, and the solar system, and organisms, and atoms and molecules, and the entire universe. All of those are probably the result of intelligent design. After all, look at all the evidence we have of specific observations of things. Human-made objects that are both complex, ordered, and functional, and also the product of intelligent design. Alright, so just like there's a method to specifically evaluating arguments by analogy, there's also a method for evaluating inductive arguments. Likewise, we ask the truth test, are the premises true? And these next 2 steps here are referring to how you evaluate an inductive argument's structure. You first want to know how many examples you have in your premises. And the more examples you have, the better. There's a fancy phrase that gets bandied about in statistics classes, referred to as sample size. If you've taken a statistics class, you know this phrase. The sample size for any given study, and by the way, a study is just an example of an inductive argument. A study is a bunch of specific observations, specific samples, and then you're supposed to generalize based off of that study that that's how the world works. But for any particular study, the sample size is the total number of observations relative to the overall population that those observations are supposed to represent. So your sample size, if you take a poll of the United States to try to figure out how many people in the United States like President Obama, you might ask 4,000 people across the country. 4,000 people will be the total number of observations. The overall population of our country is 300 million. So your sample size is 4,000 out of 300 million. So that's the idea of sample size. The more, the better. The more examples, the better. If we just have one sample, that's probably not going to be good enough. But if we have something like half the population represented in our sample size, that's probably a good sample. The other aspect is whether the examples are representative. Do we have a good solid cross-section of the overall population, or are our examples somehow biased, somehow a small, misrepresentative, unrepresentative subset of the overall population?